All right, well, welcome. In this video, we're going to be looking at how to do partial fraction decomposition. Well, what the heck is that? Well, we've seen problems like what I have here in blue in the past, where we added fractions together to try to get it as a single fraction, where we worked to find a common denominator. And once we got everything to have a common denominator, then we could combine the numerators, and we could get our answer there that I have in yellow. Now, what partial fraction decomposition means is that we're actually going to start with something that looks like that's in yellow, and we're going to break it apart into its individual pieces, the individual fractions that would combine together to give you that answer. So that's why we call it partial fraction decomposition. So if you think about the word to decompose, means to like fall apart or break apart. So that's what we're doing. We're taking a fraction and we're breaking it apart into its original pieces. Now, what I have on the next screen is the traditional method for teaching this. And this is just the first part of it. So this would be the traditional method where you end up with a system of equations like I have down here in green. And once we get a system of equations that I have down there in green, then we solve that system of equations and work to find the individual parts for A, B, and C. And those values for A, B, and C would be the values that we would have in our numerators up here. That's our goal, is to figure out what those numerators would be. So again, that's the traditional way, which works, and I'm sure you can find some videos to show you that way. But I'm going to show you a new way that is super cool. All right, so here's what we're going to do. The first thing is going to be the same as in that previous process, is we're going to set up a separate fraction for each factor in the denominator and use a distinct variable for each numerator. So you can use any variables you want. I would encourage you, since we're going to be working with the denominators are usually going to be in terms of x. So let's use variables at the beginning of the alphabet like A, B, and C, or even D if we need to have 4 fractions. So let's start with the first denominator is just, or the first fraction, or the first factor in the denominator is x. So we're going to have our first fraction would be A over x. Now we're going to have a different, distinct numerator. So we'll give this the numerator B. And then the next factor we have in the denominator is x minus 7. And then the next value of the denominator is x plus 8. So we'll give that a new distinct numerator. We'll call that C. So if we were to add those together, that would equal our original fraction, negative x squared plus 30x minus 56 in the numerator over x times x minus 7 times x plus 8. So that's your first step. Next, what we're going to do is we are going to eliminate the fractions. So to eliminate the fractions here, we're going to multiply by the common denominator, which is what we have there at the end. It's x times x minus 7 and x plus 8. So we're going to multiply each fraction by this. And again, what this is going to do is this is going to eliminate the fractions. So when our first fraction, when I multiply a over x times our least common denominator here, the x's would cancel each other out, and that's going to leave us with the a with just x minus 7 and x plus 8. So again, the x here and this x would cancel each other out, leaving us with the a times x minus 7 and x plus 8. All right, let's go to the next fraction. So the next fraction, the x minus 7 and the x minus 7 here would cancel each other out, leaving us with just x and x plus 8. All right, let's look at the next fraction. So the next fraction, we would have c, and then the x plus 8 and the x plus 8 would cancel each other out, leaving us with x, and x minus 7. All right, and then the last one, everything here in this denominator would cancel out everything here, so we'd be left with just what we have in the numerator, negative x squared plus 30x minus 56. All right, so what this new method is going to do is what we're going to do is we're going to take the zeros that we have from each of these individual factors. And let's go ahead and write those down. So the zeros, so the first zero we would have x minus 7. If I set that equal to 0, I would get 7. Then if we look at the next factor, x plus 8, if I set that equal to 0, I would get negative 8. If I go over here, I see that we have x. If I set that equal to 0, we would get 0. And then if I keep x plus 8 That gives me a 0 of -8. So it looks like we have all the zeros represented. Or we could also just look at what we have here in the denominator, or look what we have here as our least common denominator, and get the zeros from that, however you want to look at it. All right, so what we're going to do, this trick is so slick. We're going to just work with each one of these zeros, and it doesn't matter what order we do it in. I'm going to start with, you can just go from left to right. I'll just start with where x equals 7. Now what I'm going to do is in every single one of these variables, even all the way over here, every single one of those we're going to replace with 7. Now watch what happens. When I put 7 minus 7 in here for x, 7 minus 7 is 0. So it doesn't matter when I put 7 in here for x. 7 plus 8, yes, is 15, but 0 times 15 is 0. So by putting 7 in that first factor, it eliminates the a value. So let's go to the b. So if I put 7 in there for x, that's 7. 7 plus 8 is 15, so we'd have 15 times 7. We'll get to that in a second. Now if I put 7 in here for x, well, 7 times, so we'd have 7 in that first one, but 7 minus 7 is 0. So again, 0 times all of that, that eliminates the c's. Whoops. And then on the right side, I'm going to put 7 again into each one of those spots. It'll be a negative, and then a 7 squared plus 30 times 7 minus 56. Now when I go to simplify that, 7 times 15, you can do that on your calculator, that's going to be 105. Oops, sorry, it's a b. And then if I simplify the right side, 7 squared is 49 minus, and then make that a negative, so negative 49. And then 30 times 7, that's 210. So if I took negative 49 plus 210 minus 56 on my calculator, you're going to end up with 105 on the right side. So if we divide both sides by 105, I get b equals 1. Okay, so we got our first zero. Our first, first numerator. So in other words, we know at this original equation, we know that b would equal 1. So now let's use another 0. Let's use negative 8. Oops. So now when I put negative 8 in here, again, that's going to eliminate the a value, because if I put negative 8 here for x, negative 8 plus 8 is 0. So anything multiplied times 0 is just 0. So that eliminates the a's. If I put negative 8 in here, negative 8 plus 8 is also 0. So that's going to eliminate the b's. So the b's are going to disappear. But now I can put negative 8 here for x, and that's not going to eliminate the c's. So we would have c, and then negative 8, and then negative 8 times, or negative 8 minus 7 is negative 15. And then over on the right side, every time I see an x, I replace it with negative 8. All right, so let's simplify this. So on the left side, if I take negative 8 times negative 15, I get 120. And if I do the work on the right side, again, negative 8 when I square it is a positive 64, but the negative in front makes it a negative 64. So you'd have negative 64 there. 30 times negative 8 is negative 240. So if I take negative 64, negative 240, negative 56, add those together, I get negative 360. So we just found when you divide both sides by 120, we get c is negative 3. All right, let's do it one more time. Now it's with x being 0. So this time, if you put 0 in there for x, the a's are going to stick around. Because if I put 0 in here for x, that's going to make everything for my b's 0, so the zeros the b disappears. If I put 0 in here for x, that's going to make the c disappear, so then we're left with just a on the left side of negative 7 times 8, which I know is negative 56, but we'll get to that in a second. Now watch what happens on the right side. When I put 0 here and I put 0 here, if I simplify that, I get negative 56 on the right. So in other words, I get negative 56a on the left equals negative 56 on the right. So if I divide by negative 56, I get my a value is 1. So in reality, this is really all I'm looking for. I'm looking for our a value, our b value, and c value. And what we just found is that those numerators would be 1, 1, and negative 3. So we just found the missing numerators. That's the purpose in finding our a, b, and c. All right, let's do one that's going to be a little bit easier. So again, I just want to show you. I want to go back a couple of slides, though. So all of that work that we just did simplifies all of this mess. So you can pause the video. You can see if you can figure out what this mess is all about on your own if you want, or watch a video about how to do that, because again, there's plenty of teachers that teach that traditional way, and I'm showing you something new that makes this so much more easier. Let's look at this next one. Now, the only difference between this one and the previous one is that the previous one had the denominator in factored form. This one doesn't. So let's get that denominator in factored form. So we don't care about the numerator. So we can leave the numerator the same. The denominator, the a value is 1. So it's one of those easy ones to factor. We're trying to figure out what two numbers multiply together to be negative 2. That add together to be negative 1. Be negative 2 and 1, because negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. All right, so let's set up our fractions. So we would have, this time we're only going to have 2 fractions. So our first fraction, again, we can just use a distinct numerator. We'll just call that a. Our denominator would be that first factor of x minus 2. Plus, call this next numerator b. And then our denominator would be x plus 1. And that's going to equal 3x minus 3 over x minus 2 and x plus 1. All right, so our denominator that we're going to use is that x minus 2 and x plus 1. So on the left side, now you can also, some people look at this as cross multiplying. You can do that because this only has 2 terms. With the previous example, that wouldn't work quite as easily. But we would have a and then x plus 1. Or you can look at it as like we did in the previous one. Why does that keep happening? Our previous one, we would multiply the x. So for this b value, the x plus 1 and the x plus 1 would cancel out, leaving us with b times x minus 2. So whichever way makes most sense to you, I don't care how you do it. You're going to get the same answer. And then on the right side, the denominators would cancel each other out, so we're left with just 3x minus 3 in the numerator. And the zeros here would be negative 1 and a positive 2. So let's start with that first 0 of negative 1. If I put negative 1 in there, the a's would cancel out, or they would disappear, because negative 1 plus 1 is 0, so 0 times a makes the a disappear. So for b, negative 1 minus 2 is negative 3, so I'm just going to write that as negative 3b. And on the right, 3 times negative 1 is negative 3, minus 3 is negative 6. Divide both sides by negative 3, we get b is 2. Super easy. Okay, let's do when x equals 2. So when x equals 2, we'd get 2 plus 1, which is 3, so we'd have 3a. We put 2 in here for x. 2 minus 2 is 0, so that eliminates the b. Then on the right side, 3 times 2 is 6. 6 minus 3 is 3. So we get our a value is 2. And literally, that's it. We just found our answer. A is 2. Oh, sorry. Mr. Murphy. Let's do our math. 3 divided by 3 is 1. Getting messed myself up there. 3 divided by 3 is 1, so our a value would be 1. And our b value would be 2. So in essence, 1 over x minus 2 plus 2 over x plus 1, that would simplify to be 3x minus 3 over x minus 2 times x plus 1. But all I care about is these values, so I just want to make sure you know how to find those. But the reason why we find those is, again, we're just finding the numerators. So I want you guys to try one on your own. So I want you guys to try this one on your own. So go ahead and pause the video and hit play when you're ready to check your answer. All right. So you should have gotten your a value is negative 5, your b value is positive 8. If you didn't get that, pause this video and see if you can figure out where your mistake was at. All right, so that was just one case where we have linear factors. There's all these other cases We're just going to look at case number 2 and we're going to end there. So case number 2 is if we have repeated linear factors. What does that mean? Well, if you're in my classes and you have your homework packet, you can look at this problem on number 2b in your homework packet. We're going to work this one out. So here we have repeated linear factors, meaning we have x minus 5 being squared. We're going to do this the same exact way, just a slight difference there with having that denominator of x minus 5 squared. So we would have our two fractions would be a over x plus 1 plus b. Leave this as x minus 5 squared. Don't write it as two separate fractions. Don't expand it out. Just leave it as x minus 5 squared. And that's going to equal what we have on the right, 4x squared minus 32x plus 72 all over the factors x plus 1 and x minus 5 squared. So from here, you can see, I'm just going to go through this one a little bit quicker. It's the same process. You multiply by the least common denominator, cross multiply, however you want to look at it. But you end up with a times x minus 5 quantity squared plus b times x plus 1 squared, or just x plus 1, sorry. And then the right side would stay the same, just the numerator. And our zeros being a positive 5 and a negative 1. So if we use 5, that's going to eliminate the first term because 5 minus 5 is 0. 0 squared is 0 times a, so we eliminate the a. For our b, 5 plus 1 is 6. We have 6b. Oops, sorry. Trying to go too quick here. We put 5 in here for x, sorry. I just looked at the 6. It's 5 was what we put in for x. All right, so when we simplify that, we end up getting 12 on the right. Whoops. There we go. So when we divide both sides by 6, we get our b value is 2. So we just found that, again, this numerator would end up being 2. So now we're going to use the other 0, negative 1. And when we use negative 1, now the a is not going to disappear. Negative 1 minus 5 is negative 6, but when you square that, it becomes a positive 36. And then negative 1 plus 1 is 0, so the b disappears. And then on the right side, we would have 4 times negative 1 quantity squared minus 32 times negative 1 plus 72. And I believe you end up getting 108. Yep, that's 108. And then the next thing we do, the last step, divide both sides by 36, and we get our a value is 3. So we just found, again, our a and b values would be 3 and 2. So that's really no different when we have a square in there. It's just looks a little different at the beginning. All right, so that's it. So that's how we use this partial decomposition of fractions using this new method. So if you're in my class, your assignment is just to do numbers 1 and 2 in your homework packet. We did number 2b together. So you only have 3 problems to do in your assignment. So go ahead and work on that, and good luck as you work on that assignment.